control modification. First is this BSD fault relay will shut down all the control circuit, including the valve and the two valve individually. And this is also been modified, so any of those compressors shut down, the module will shut. No, any of this one will run. It will open and give the run command to the one expansion valve. So it's all same with this one also for the compressor. Line 2 compressors have its own interlock on this valve, so to prevent any flood back. So this one also was controlled by the temperature. So with this valve, there are 4 interlocks with this one: the relays, the temperature, and the compressor starts up. So this is all controlled by this one. And the next one is this relay setups and the timers. So this line 1, line 2. So what this controls the solenoid upon the run command coming from the main controller inside the plant room. This will trigger to start to run open the solenoid, and this will deactivate. Once this deactivated, this will run and give a run command to the switches, which is here on the switches. So this is all the modification that I've done and added to the controls with as added protection. Okay, so the purpose of this sequence is to delay the shutdown during upon shutting down from the plant room. So to give way for the pumping down the system. So the solenoid will close because it is hooked up to the normally open condition. So once this is deactivated, the solenoid automatically close, the liquid line solenoid, but the timer will still give this whole system a run command to conduct a pump down system. So what happened in that condition is that during the day, upon startup, it will not have a low polar condition, where what happens is, because this has been running at lower temperature, so it migrates much of the liquid refrigerant in the barrel. So that's what we wanted. We don't want to happen during the startup, because there are multiple cases that we having some issue with flooding back at the morning time, so it will not run as normal. So this is the way I set up this one. So it will prevent everything. It will work normally as it should be to protect the system. And this has been also set 9K or 9 degree superheat already. It's been adjusted. We're running well. This is also been adjusted, our 2 tanks temperature, which is this drives also the expansion valve. So this one is for the pre-cooling time. Previously we set at 3.5 degree for both of these tanks. So what we do is, because during the later time of the day, we're having a hard time to bring down the temperature already. So what we do is to set at lower at 0 degree our water temp inside the tank, which in way during the pre-cooling stage, before their plant operation starts, we already have we already pre-cooled our water. In that way, even when the time of the loads starting on, we have a sufficient temperature of the water, which in way we could delay the increase gradually during the later part of the day. So that's how explains this control circuit that I was doing some recommissioning of this system, bean chiller, glycol chiller. So this is the one that I was doing for quite some time now. That's it. Thank you.